Hey Pre-Calc, back with another video. It's the second part of section 1.6, this first lesson of solving inequalities. So we got past the basics. Now let's talk about, this is kind of a special case that doesn't show up too often, absolute values inequalities, at least in your previous math classes. It kind of gets thrown out there and then you don't deal with it a lot later on. Read page 67. It does a good job of explaining things, mapping things out, where you guys can kind of get the context for, oh yeah, that's what this means, this whole idea of there's a number line and it's a distance from zero, ... I'll let you guys read that. But on page 68, they do a really good job of showing the properties for what the heck are you supposed to do if it's less than, and how is that different from greater than. They state the absolute value of A is less than B is equivalent to the statement negative B is less than A, which is less than B. So when you unpack that, this is sort of like their first little property of absolute value inequalities. It's sort of like saying A is less than B comes from this statement, okay? Also coming from this statement is negative B is less than A. But I think it's probably more helpful to rewrite this as A is greater than B to almost help you see the pattern of what's going on here. The pattern is I can just drop the absolute value bars and solve. Then I can do an alternate version where I drop the bars, switch the sign, and then make the opposite side negative. That's kind of your procedural task when its absolute value is less than a constant on the other side. So let's work through that on number 17. Absolute value of x plus 3 is less than or equal to 1/100th or 0.01. We can split it up into A is less than B. That's x plus 3 is less than 0.01. That's kind of our A is less than B in this situation. And then we've got x plus 3 for our other one is greater than negative 0.01. So that's one way to think about it. And we would use the conjunction and to talk about this because if they're connected in a statement like this, it's sort of like saying, hey, we want the shared space between these two inequalities if they were graphed. Usually it's just the stuff shaded in between the values. So when you take 100th and take away 3, it's the same as taking 3 minus 100th, slapping a negative on there. So x is less than negative 2.99, okay, for your first statement. And I'll try to do one of these ampersands, yeah? Little and symbol. Minus 1, minus 1. This is going to be x is greater than negative 3.01. And that's basically your solution. You can rewrite it as negative 3.01 is less than x, which is less than negative 2.99, or parenthesis negative 3.01 is less, or comma, negative 2.99, and then a parenthesis on that side too. And I believe they said express solutions as intervals whenever you can, so I'm going to leave that as my final answer. So hopefully that makes sense. And here's something else you can do. You don't have to split it up into two separate inequalities and solve it. If it's simple enough here, what you can do is say, I'm just going to put the A inside the inequalities. All right, so an alternate approach to this is put the x plus 3 sandwiched between negative 0.01 and positive 0.01. That's kind of like what this statement with the little curly brace is saying. minus 3 here, minus 3 here, minus 3 here. That gets you to the solution really quick without having to write a whole lot. But, some people, they like the structure of, let's just make it simpler. I can solve it and then make sense of it. All right. What happens when it's a greater than instead of a less than? If it's A, absolute value A is greater than B, the textbook states it's equivalent to A is less than negative B. And they use the conjunction or, not and, or means the union of two solutions. A is greater than B. All right, so it looks like we're just dropping the bars and solving one of them, just like we did with the and statement. So that's what I'm going to do on this one. Drop the bars, solve it as normal. Now remember, when you divide by a positive number, this doesn't change. It's still greater than or equal to. All right, so x is greater than or equal to 4 is one of my solutions. The other one is going to be separated with or. Looks like we're dropping the absolute value bars and then switching the sign and making the right-hand side negative. That's pretty much what we did over here. You can't see it, of course. We dropped the bars, flipped the sign, made the other side negative. So that's what we're going to do over here. Drop the bars, flip the sign, make the opposite side negative. Solve. And there we go. I think the intention was when they throw this on the left first, it's kind of showing you that on a number line, this would be going in the left direction, this would be going in the right direction. So now what's the best way to write that as an interval? Well, this would be less than, so negative infinity would be our starting point. We'd put a bracket on the 2/3. We would start with 4 when it's greater than or equal to, and end with infinity with a parenthesis. Now, I'm not going to be too picky, but, recognize that the clear way of representing this solution is going to be with a union symbol between these two. And usually they start with the leftmost, union with the rightmost. Starting with negative infinity, you've got this, and then the U symbol for union. It's kind of like your or statement. That's proper notation. Okay, so we mapped out the less thans, we mapped out the greater thans. What is significant about number 21? Well, in our previous examples, we didn't really compare it with a negative constant on the other side. So let's think about the nature of absolute values. These bars create a positive number, whatever is inputted in here for x. So I could input any number from negative infinity through infinity. No matter what happens, this is a positive number. There's no way around it, okay? So let's think about that statement. We're always asking a question when we solve one of these things. We're asking the question, what satisfies this equation or this inequality to make the original statement a true statement? So what satisfies the statement, a positive number is bigger than a negative 2? What could we plug in there that would make the left-hand side bigger than negative 2? And I just answered it before, right? I said from negative infinity to infinity, whatever you plug inside here is positive. So everything I plug in is going to be bigger than negative 2. I don't even need to solve this thing. All real numbers are solutions to this inequality. And here's the thing. If you worked out the solution and tried to think about the union of the two solutions, it's going to be, instead of looking like an OR graph where they go in opposite directions, it's going to be an OR situation where they cross over each other. It'll be something that looks kind of like this on the number line, which means the union of those two graphs is every number imaginable. So I don't know, that's kind of a tricky special case to kind of wrap your mind around, but I'm just going to leave it at that. All right, number 25 in the textbook. This one's a little bit different just because it nests an absolute value in between the inequalities. So you've got sorry, I don't have this memorized. Negative 2 is less than the absolute value of x, which is less than 4. So they're creating complex structure for us on number 25. Let's make it simpler. We can solve negative 2 is less than the absolute value of x. A connected statement implies an and situation. So then we can say, and this is our other one. The absolute value of x is less than 4. All right, I'm going to rearrange this one. Just to see it better. Visualize things better. Can you see all that? Yes, just barely. And yeah, we'll just drop this one down too. All right, now I just talked about this. We know what this solution is. It's all reals. By the way, here's the symbol for all reals. This is a legit statement. Drop the bars. It's going to be in less than is an and statement. Oh, couldn't we just do the whole thing where we say, make this positive here and this negative over there? Yeah, we can do that. So now here's the question. We had this and statement here, which means you would only express the solution as what those two share, what they share. So if you looked at this equation on a number line, I'm sorry, this inequality solution is basically everything on the number line forever and ever and ever. This starts at 4, negative 4, and ends at positive 4. So this space beyond the 4 is not shared, and neither is this space beyond the negative 4. This is our solution. So it should be negative 4 to 4 with parentheses. All right, last one for this video and for this section is number 51. So number 51 gives us on part A, an absolute value equation. Part B, it gives us this inequality. And part C, it gives us this inequality. They say solve part A and use that answer to determine the answers for part B and C. So they're basically saying, hey, if you solve the equation for these inequalities, then you really only need the solutions to the equation to figure out the rest. So the equations for part A are going to be, you drop the bars, set it equal to both plus and minus. So I could just do it like that. X plus 5 equals 3, x plus 5 equals negative 3. So then if I subtract 5 from both sides, I get x equals negative 5 plus 3, which is negative 2. And I get x equals negative 5 minus 3, which equals negative 8. So here's what it's saying. It's getting after this idea that you should know that it's not a special case because 3 is a legitimate, it's not a negative, right? You can write your solution as x in the middle is nested between these two solutions. So which one's the smaller one? Negative 8. Which one's the bigger one? Negative 2. Those are our solutions. And then you could do the same thing on the bottom. If it's a perfectly legitimate OR solution, which doesn't have a negative over there, you can say, well, x is going to be less than the smaller amount, or x is bigger than the larger amount. So yeah, they're just they're trying to help you see that pattern so that you're not always having to, redo, I don't know. They're just showing you the shortcuts here. All right, that's all from me. Hopefully this was enjoyable, helpful, and we got 1.6 out of the way. Woohoo!